unprecedented amount of growth is there. Okay, and broader population, noise data, heterogeneous data, diverse scale, there are other features also are there. And after that, you can see consumer and physicians are see just nowadays the people just they are monitoring their BP and all other things by using the mobile phone itself, right? Nowadays, it is giving such kind of assistance to the people rather than approaching to the particular physicians or doctors like that. Some report is showing, and some important pillars in data analytics are people. Yes, we are the one who do this analysis for this data analytic part. Just we keep on generating the data, and we are processing that moves towards to the technology. Okay, so these are the pillars, and this is example of answer which is taken from Azure, thanks to that. And just we have just it is like the data. It comes from the structured or unstructured manner. After that, it applies into the images. Then it pushes into the leg storage. Then it moves to the snaps part. Then it applies the preparation or targeting the training data. So then it gives the classification or prediction apply in the business logic. Okay. Suppose if everything is done, they will build into the web application. That's it. Okay. Now after that, big data. What is this big data? That is, you can say data about data, data of data, data square, data like. Okay. So big data refers to the tools, processes, and procedures allowing an organization. Under that, it creates an organization. It helps the organization to manipulate the data and take the decision. Okay, creating the larger data sets and making the things to be useful manner. Okay, so this is the main thing. It has the volume, veracity, velocity, variety. Okay, it has many characteristics as well. So after that, big data challenge in India. So the excellent thing is it is available in different velocity, different dimension. So we need to reduce that. We need to find the enough future. We need to put the futures into the model. It will be a tedious job by handling this big data. Let me read a few. Understanding unstructured clinical notes in the right context. So unstructured clinical notes, definitely it will be a biggest issue. Just now I stated, no, we need to find the useful thing. We need to find the useful pattern from the clinical note, right? So like this, we have a lot of challenges, and the main goal is just bringing the maximum data by applying the cost. We need to get the more and more good out. Okay, by taking the smarter and smarter, better decisions. That's the thing. And some of the motivation exam are working in the health area. So that means over $30 billion was spent on unnecessary hospital admissions in early. I mean, it was there in this website, and there is identify patients at a high risk admission. They have get the enough treatment if they have need, right? That all means just we are going to this necessary thing, reducing the number of unnecessary hospitality or hospitalization of the people, patients, and increasing the cost of the care. Okay, because then they will be economics will be high, and this is another that means the patients for poor care. That means they are not caring properly, and it just brings again and again in this section. It was creating a big issue. Like within a 30 days of the previous discharge, they are able to. I mean, they are going back again, and sudden heart failure, heart attack. I mean, there are many other things. Okay, here the identifying the patients at the risk of readmission, it can guide the efficient resource utilization. That means it can usually utilize the resource of the hospital efficiently. So in that way also that they can see progress growth hospitality. Okay, and after that the one is answer brain initiative that is introduced by Obama, just like bringing the innovative brain to the future. Like every dollar we invested map the human genome returned as the economy. So today our scientists are mapping the human brain to unlock the answers like Alzheimer or some other diseases. Okay, so that means that they are investing more and more, like $100 billion, millions of dollars for innovating this. This is also another thing. And after that, this is a GA head health challenge. That is in our in Europe, in other countries, they are just giving more and more focus to the football, right? So there may be a lot of chances of getting the players maybe injured frequently. It may have the knees or head, shoulder somewhere, right? So this is working for head only. Just they are introducing the challenges like methods for diagnosis and prognosis of mild traumatic brain injuries. It should be identified, or challenge to the mechanisms of injury, mechanics of injury, innovative approaches for preventing and identifying the brain injuries. This is also another thing. That means, if they have, there'll be a reward like $10 million for the two things, right? So in that way also they are introducing the money, investing the money for them. And after that, data collection and analysis, how the data could be collected. So it could be in the form of anywhere, like it could be coming from pharmacy side, maybe in the prescription, developing the medicines, okay, and like it's small setups to the tablet, something like that. And after that, it can collect from the laboratory side. It may coming from the radiology, either X-ray or scanning report, something like that. Okay, digital documentation and so on. That is text analytics for narrative clinical notes. Okay, it could be in this order. All this will be applied in the database, right? It will be having n dimension because the data set will not be able, will not be the same, right? And it will be updated whenever the customer change. The thing it is very difficult to identify. So it can be classified as point of care. A statistic report can be taken for the laboratory result, and they will do further analysis for the RX normalization and that is the pharmacy report and the analytic method. Okay. So sources and techniques, how it could work. So it can be collected from electronic health records, that is EHR, and healthcare analytic platform and resources. These three things we are going to discuss now. So data. So data, it could be either genomic data, DNA sequence, RNA sequence. It can be coming from other part as well. And clinical data, we may have a structured EHR, that is electronic health record, or unstructured. Even it could be a medical image. And after that, behavior data, social analytics and mobility sector, mobility sensor. Okay, after that, the health data will be analyzed. And there is the first thing, billing data, that is coming from ICD, that is International Classification of Diseases. Like it classifies the disease, like by looking the signs, symptoms, what thing they have consumed, what they have eaten, and what the whether they are following the diet or not, something like that. Okay, by looking that, it classifies the disease, and this is the sample data. The pros is universally available; it can be available globally. The cons is a medium recall, so it will not be, it will not provide that much accuracy of the results. And after the billing data, CPT notes, CPT codes, that means your clinical notes will be bringing to the next level by applying the coding mechanism in the realm of medical. I'm just talking, and this is the report that I have collected from AM, that is Medical Technology Assistant. Okay, and it produces high precision row recall values, and then after that, data could be collected from lab results also. And after that, medication, and after that, clinical notes, what they have prescribed, what they have given, evidence, and all stuffs. And those will be presented in table format, like look at that medical notes and lab, CPT, ICT. So after that, it will be mentioning that either this data available very risky, or if it is not risky, then high available, no issue. Recall value, precision value, for what type of format that it is following. Everything we need to be reported, we need to be collected. Okay, so we have done just the data part, and after that, analytic platform. So analytic platform, we have three important things, that is information extraction, feature selection, and predictive modeling. So what is this? That is information extraction, information retrieval. You are going to retrieve something from the image, video, audio, something like that. Okay, like we are going to find the cancer by looking the particular point, by selecting the region of interest, something like that. Some specific future will be identified for getting the information. After that, a future selection. We are going to select the future. Okay, we can pick this feature. We can go further like that. There are some useful algorithms also there for selecting the future selection. That is like we can say that is a Boruta model, something like that, and the predictive modeling. Whether we are going for the classification or prediction. Okay, such thing we can also do. Like linear regression also we can apply, either logical regression, something like that. Okay, and information extraction, just the information, it could come from the structure oriented data or unstructured data. From that we are extracting and we are converting it in representation model. Then we are pushing into the predicting model. Okay, after passing through this future selection. And this is the first text mining in healthcare. So text mining, just mining the text. We are taking, I'm just taking the text, I'm just performing mining process. Mining means trying to find the useful information from the text. That's it.
Sir? Excuse me, sir. Sir? Ramkumar, sir. Dear participants, kindly fill the feedback for the time being. Let's until sir gets in.
Ramkumar sir, sir, are you online? Deepika, are you online?
Yes, ma'am. Yes, ma'am.
Thanks, Dr. Ramkumar. Dear participants, if you have any query, you can post them in the chat box. Avoid unmuting yourself. We have Mrs. Deepika to propose the vote of thanks for the session.
Thank you, ma'am. Good morning, everyone. It's my pleasure and privilege to thank the resource person of today's FDP's first session, Dr. Ramkumar Krishnamurthy, Assistant Professor, Science and Technology, Vishwakarma University, Pune, for kindly accepting the invitation and sharing his knowledge with us. The session was very useful and informative. My sincere thanks to you, sir, for providing us a wonderful session in this morning on data analytics in healthcare. Thank you, sir. I sincerely thank all the participants from various colleges for their active participation in this session. Once again, thank you all.
Dear participants, thank you for bearing all the difficulties. Please join us after the break at 11:20.
Dear participants, a kind reminder, in afternoon session, we are going to have the assessment from 2 to 3. And few of you can give some online feedback. And we'd like to take a photograph during the validity function. So kindly switch on your video for a photo. Thank you, friends. I'm really sorry that we are not able to give the presentation of Dr. Raj Subramaniam. Kindly pray for him. Till last week, he was talking with me. Really, we missed a nice talk. That's what I feel. And he was ready with presentation, everything. But due to sudden demise of his mother, he was not able to deliver his talk. I really feel very sorry for the inconvenience. Thank you, participants. You can leave and we'll meet again by 11:30. Thank you, one and all.
Oh, I'm so sorry, ma'am. Actually, I think it left. Ma'am, can you hear me or not? Hello, ma'am. Oh God. Hello. Am I audible, ma'am? Can you hear me? I'm not getting. Hello, ma'am. Can you hear me or not?
Audible, sir.
Oh, sorry. I don't know when I have left. I'll just continue, ma'am. Please,
Sir,
can you hear me,
excuse
sir?
me, sir. Sir, excuse me, sir.
Yes, ma'am. I'm so sorry. I think I left. I don't know when. From where I have to start, ma'am.
Oh, please wait for 5 minutes, sir. 1 minute, sir.
I'm so sorry, guys. Actually, I don't know when I have left.
9 class.
Arakirat sir? Arakirat sir?
Ma'am?
Sir, good morning.
Yeah, good morning.
Sir, you can start, sir.
Okay, ma'am. First of all, sorry for this. Actually, I had disconnected with my internet connection. Just now, I'm going to give you a simple real-time example. We are going to work for cancer data set. Okay, just I'll show one simple demonstration. And let me share the screen first. Ma'am, is it visible?
Yes, sir. PPT. No, now it is not visible, sir. PPT is not visible.
No, ma'am, not really. Just my is there. Still, I'm opening the Google Class. Can you see that?
No, sir.
Really?
You present, sir. Present it.
Okay.
Present
Okay.
and then.
Okay. It's a one platform. Name is Cola. Okay. So this by use
Sir, it is not clear. Sorry, sir. Ramkumar, sir. It is not clear. You
wait.
present your audio. I'm sorry, your PPT.
Ma'am, actually, I'm not presenting PPT. I'm just showing my browser.
That's what.
Understand?
You
Yeah.
share your screen and then do that, sir. Participants, kindly mute your audio. We are listening some unwanted sound. Kindly mute your audio.
Is that okay now, ma'am? Can you see my browser?
Yes, sir. Yes, sir.
Okay. Okay. Yeah. Thank you. So here, this call app is you can use this call app for you can do many things. You can implement the machine learning algorithm and a lot of things. Okay. For doing this, what you have to do, just go to your drive. Okay. For your respective, you just get into that. Just give me a second. It's processing. I think it is loaded. It's okay. I'll just tell you. The thing is, I can select this caller window from this drive of your institution ID. Okay. So just go to your drive. Okay, it's okay. Let it be. Okay. So after opening that, having environment. Okay, they will be having list of menu items. Then the top you can the name of the file. Okay, suppose you want to change it, if you want to do it here, it's your choice. Okay, so here in the left hand side you can see the needed.
Sir, your audio is not clear, sir. Kindly use headphones, sir.
Is it fine, ma'am? Ma'am, just give me one minute. Now can you hear?
Yes, sir.
Hello. Okay.
Yes, sir. Proceed.
Yeah. Yeah. Okay. Okay. Thank you. Okay. So here in front side that you can upload your data set, you can upload your files, all other stuff that you can do here. Okay. And after that you can do you can view the drive, you can push this file by doing all these things. Okay. In the right side you can see that storage using the discrete. Then telling using institutionally, you many tasks that you can do help of your institutionally. Okay. In your particular Gmail, if you have individual ID means there will be limited storage. That's okay. So how can you confirm the devices it is getting ready means you can see here this option will be there. Okay, it is connected to this app and all other things. Okay, for using this you should have Python. Okay, now just I have given some description about this. Okay, now let me write the thing. For example, if you want to insert a new thing here, just click on code. Okay, once if you are code, then you can think. Okay, just if you want to do compile the data. So after that, it can exit just clicking. Sorry, you can directly here. Okay, you can. Okay, by doing this, you can write many sub here. Okay, and suppose if you want to bring this
Nothing
code
is visible in the screen.
snippet.
Is it still loading? Ramkumar, sir?
No,
Only white screen is there. It is still loading.
happens also. Any participant respond? Can you see my browser window?
Sir, we can see your browser, but
Ma'am, for me,
it is displaying as loading only.
I don't know what's happening. Wait, man. I just share it. Okay.
Some
I have
warning
shared
message
my.
is the screen now.
No, I have shared my entire screen, ma'am, but I don't know why it is happening. Now,
No, sir. Now only you are starting presenting it. Yes.
now can you see the
But
just
still,
something. I'm just display some code snippets that I'm navigating. Is it visible too? Just is it visible to you, ma'am?
yes, sir. Yes, sir. Now it is visible. Yes, sir. Now it is visible. You proceed, sir.
Thank you. Okay. Yeah, the thing is here I have said that you can upload our data set. Okay, and in this side you can see you should get confirmation. Suppose in sometimes some messages like connecting that. In that case, you should confirm that okay, created the match. That's the thing what to do. After that, if you want to simple changes, if you're doing even if you're doing a small change with your data set, with your code, what you have to do immediately you can do this save option. Or you want to take a copy, you want to Xerox this location, you can put it to this one like a save copy in drive. Okay, all others can just menus. Okay, sir, you may have a question like I want to put the data. So how can I do that? This is a great thing from some file here. Okay, let's say you can download it. If I have some. So okay, you can So for example, I'll cut this data. This is very simple. Okay, and you want to just keep drag then leave. Okay? Say just keep and you just drag on the browser. In the div you can do here. Okay, the file will be available. Be uploaded here. You can see that is progressing. Quite okay. Suppose once if you have uploaded, you'll to see the file here. Okay, so let me see. It's let it be. Now explain this code. This is called snippet. Okay, like this you can add a number of snippets. let's say if you're working here code, you can keep on adding the things, adding the substitutions, okay. And if you want to put up, you can do like this, up and down, okay. And it is upwards also, you can do it, okay. So after that, after this, just let me explain the code. Here, suppose you want to take this data set, it is available in Kabul website, that you can get it from internet, okay. And these features like this number of attributes and the properties also there, and attribute information like thickness, the column infinity of the cell size, shape, and the marginal, elliptical, cell size, nucleic, chromatic, everything will be there. At the end, you can see that there is a class file, right? Very, very important, because in the machine learning, we are going to use this target file by having these attributes, these features, okay. So how will you apply this feature selection here? So from these futures we are going to take, okay. There is a concept called Boruta, okay, that method we use to perform the future selection, that will rank your futures, okay. And after that you find this belongs to this bin class or main class, like that, okay. So now let's start code one by one, okay. So here you can see prepare data set for machine learning. I have already put the data set here, okay. After that you can give the sync from this one to this one by typing the code. Then you can see the data set, okay, code pandas, pandas PD, okay. It's an identifier for pandas, that's library, library to perform this iterations. So here, so it is showing some issues. So you can see here it is still loading, and it is showing some issues. That means that due to the internet issue, it is coming like that, okay. You have to wait, so let them complete. After completing that, we'll be able to proceed further, okay. So now what you have to do, if you are clicking the cell, each and every cell, you can run it. This, you should install the system. That's it. Other than nothing, you need to go from this drive. From this driver, you'll be able to do the rest of this, okay. Now the pandas PD is created. After that,
Kind of பண்ணிடுறோமா? ஏதோ ப்ராப்ளம் இருக்கு. ஆரக்கிற சார் வந்துட்டேன்.
Yes, ma'am.
Sir, shall we start your session?
Oh, yes, we can use.
Yes, sir.
Can you hear me, ma'am?
Yes, sir. You are audible and visible.
Sorry. Thanks a lot,
Just a
Dr.
minute.
Ramkumar.
Yes, sir.
Thanks a lot, Dr. Ramkumar. We have Mrs. Deepika, who have already proposed vote of thanks. So thank you, sir, for sharing your expertise in our busy times. God raises the lowly and the humble and seat them in the hands, kings and lords. Amidst us, we have such an inspiring personality, Mr. Rdf Raj, Senior Architect in Immersive Mortgage Corporation, South Carolina, USA. One tree can start a forest. One word can frame a goal. One candle can wipe out darkness. A true leader has the confidence to stand also. He is a man of virtue in helping many emerging coders. He is an avid coder, software developer, and a passionate teacher whom we can reach at ease for any basic doubts in software development. He is known for many of his software products. We, the Holy Crossians, are lucky to use one of his such products before this MAS developed. I call upon Mrs. Magdalene Mary to introduce the speaker of the session.
With a note of acknowledgement to the Lord Almighty for His grace which has brought us together for this AACT Faculty Development Program on Integrated Data Analytics, the tools and application around industry verticals. I commence with a pleasant task of welcome the gathering. A very good morning to one and all gathered here. A smile is the universal welcome. It is my privilege to welcome and introduce Mr. Arakiraj, Chief Software Architect, Amerisafe Mortgage Corporation, USA. He completed his UG and PG in Computer Science at St. Joseph College, Trichy. He worked as principal engineer in the US and also on architects for several consulting companies like Wipro and CTS. He is CTO of the company which has developed XML-based business engine to develop business application with less resource and technology independence. He specialized in web service-based Java application. We privileged to have such an eminent personality among us. We cordially welcome you, sir. I extend my warm welcome to all the FTB participants of today's section on Graph Analytics Neo4j. Once again, I welcome to all. Thank you.
Thanks, Mrs. Magdalene, for your amicable and warm welcome. Gary Wolf says, fortunately, human forgetting follows a pattern. We forget exponentially. A graph of our livelihood of getting the correct answer on a quiz sweeps quickly downward over time and then levels off. Graph is everywhere in our social network, when you order your food online, and when you travel by Ola and Uber. Here is Mr. Arakiraj, who is going to take us into the world of graphs. Over to Mr. Arakiraj to share his expertise on graph analytics.
Thank you,
Welcome,
Ms.
sir.
Thank you, Ms. Nirmala and Rosalind, for giving me an opportunity to share my knowledge and experience with you guys. And I'm, as always, as a Trichyite, I'm always excited to meet you people and work with you guys. So let me share my screen, okay, and see. Let me know whether it's work. You're able to see it or not, okay. Are you able to see my screen now? Wait a minute, I'm sorry.
No, sir, your screen is not visible.
Okay, one second. Are you able to see now?
Present your screen, sir. Yes, started presenting. Yes, sir, it is visible now.
Oh, it started presenting, okay. You're able to see it, right?
Yes, sir.
Okay, thank you. One second, and let me just set up my system a little bit so that I can see you guys all the time, okay. All right, here we go. So today we're going to talk about graph analytics. It's a little bit newer topic, and because we are able to represent data in graphs. I know it's almost the afternoon, your lunch hour, so I will not pick your brains too much, and I will make sure you go for lunch on time, okay? And the reason why graph analytics is becoming interesting nowadays is because we are able to understand and form relationships between objects easily, unlike in the earlier days. And we'll see how it is difficult in other systems to create relationships. For example, today's meeting, we can analyze people who are hungry versus people who have scored marks in the test that they're going to give you at the end of the session. And people who are hungry, probably they did well or they did not do well. So you understand basically, or people who are married, they did well versus people who did not marry. So all those relationships, it could be tons of them. It's not just two properties. It could be about the city where they lived in or the college where they studied. All that linkage, you can find out what properties are required to get a good mark, okay? And those information are used in machine learning. And that is why graphic analytics is becoming very, very popular, because we are able to discover new relationships. One common example that we can think about is, say, coronavirus. Now, how do you know what is the symptom for coronavirus? So what we do, we take each person who has coronavirus, we ask them, hey, do you have a headache? Do you have vomiting sensation? Did you lose taste? Did you lose you have chest pain. We keep on getting that information from different users and we try to map it. And then we say like, hey, you know what coronavirus means? You will have these are the symptoms, basic symptoms. And not only that, now since the information is coming from many countries, it is possible that people in India have a different symptom versus people in the US because their lifestyle is different. Which also we are seeing right now, right? Because the second wave is different when compared to the first wave, and the second wave in US is different when compared to the second wave in India, and there are a lot of other factors too. But to analyze all this relationship, graphs are becoming very, very, very useful. Okay. All right. So we're going to see what is a graph, and we're going to have a small demo on that. And then we're going to see the different graphic analytics types and some of the research topics. And graphic analytics is becoming more important because they're able to aid machine learning. So any machine learning guy should also be aware of this graph analytics. And I think sometimes graph is thought as charts and bar charts and pie charts. No, they are not the graph that we are talking about. They are more on statistical nature. So that is not what we are referring. Okay. So graph theory as such is not very new, or it's not pretty recent. It has been there like centuries ago, where they wanted to know, like for example, the one that you're seeing there, the one second. You see, this is a river here flowing in the city of Königsberg, and you have these arrows point to the bridges. So when the mathematician, or when some of the people, when they just met, they were asking the question, can I go to all the bridges without traversing it twice? Can I visit all the bridges? And then they developed a small theory around it. They represented it as a graph. Here you can see how it is represented as a graph. And this is the map that they have. And based on this, they proved that no, you cannot visit all the 7 bridges without visiting it twice. There are some theory behind that. You can look it up on the internet. And this part of mathematics, we call it as discrete mathematics. But even though this is what the mathematical professor defines it as a graph, but our computer science people have extended it so that it's more useful for analyzing data. But this is what is the basic idea of where graphs have come up from. Okay. All right. And you can also stop me anytime if you guys have any questions. And graphs are everywhere. And the graph analytics, it's a different problem when compared to the graphs that I just showing you on the slide. When the data is too huge, then the problem is different. The way you solve it is different. So graphs have been all along with us, not only from the time of bridges. Even if you take the example of a mobile network that we're using every day, each network can be considered as a node, and the wire connecting the 2 networks can be considered as an edge. And based on this, they will do some analysis to understand a single point of failure. What single point failure means is one tower goes down, how many people will get affected? If 2 towers goes down, how many people will get affected? That is what they're going to think about. That's what they analyze in mobile networks. If it's going to be too many, then they're going to put more mobile networks there, mobile towers. Otherwise, they may take off the tower if it's not that much useful. Okay, so that is where we're using it. But as you all know, the number of mobile towers is not too huge for it to be used in a graph database. You can just use it in a relational database itself to analyze it. And similarly, we have this transportation network, which is like a train and our road network. We try to find out what is the shortest path. And we have already, you guys would be aware of this Dijkstra's shortest path algorithm. But remember, these are not big data. They're not huge. Like we don't have billion stations, train stations, or billion bus stops. It's not that high to be considered for graph analytics big data. Okay, but these are also graphs, and we can apply graph algorithms on these two. We can find out what is the shortest path, what is the the single point of failure, which is nothing but the connectedness, how easily can you make it disconnected, all that analysis wise, I can do it on any graph network. It's the amount of data that matters. Okay. Okay. So let's take an example of this. I think the letters may not be very clear, but I'll tell you what it is. This is nothing but friend, and this is listen. This is again another friend. This is watch Netflix. They cook probably chicken biryani, and this one is they like this network. Okay, so this is how you represent a graph in a Facebook kind of environment. So you have a person, and there are a lot of links around you. Like it could be a friend because you listen to a music, or you watched a movie, or you posted a comment, you clicked on a like button, or you reposted it, or you started a group, or you joined a group. All these activities can be represented as a graph. We'll see why should we even represent it as a graph in the first place. And you can see in Facebook when you log in, it will suddenly tell you like, hey, this you might know this person. That is possible because of this graph thing where they try to connect a couple of edges to see whether, hey, is he a friend of a friend? Okay, then they say like, if for example, in this picture, no, this person is not connected to this person directly. So Facebook will say, hey, you know what? You have a friend here who knows this person. Okay, so this is called friend of a friend. So this is how Facebook will suggest. Facebook will see, hey, how far is this friend? Is he just 2 levels down, or is he 3 levels down? Obviously, it is not going to suggest somebody who is 10 levels down, but it will only stop with 2 or 3 levels. Then it suggests like, hey, he can be your friend. Okay, so that is why this graph analytics is very important. And there are other uses also, like how do we determine community? How do we know people have similar tastes? All that, you'll see that. Okay. In a Twitter kind of environment, each person is a node, and what do? They follow another user, or they post a tweet, or they may retweet, all that. So this also can be represented as a graph, and you'll see in the next screen why these are very, very important. Okay. See, this is a Twitter graph. I mean, they have taken the Twitter data and they plotted it like a graph database, where each orange represents a very important person here. And you can see a bigger circle for Donald Trump because he's very, very active on the Twitter platform. He tweets and he retweets other people's tweets. So a lot of people are looking at him and they are following him also. But look at, on the other hand, Joe Biden, who's the current president of the United States. Not much activity is there because he's not an active person on Twitter. So what this graph tells you is Donald Trump is a more influential person than Joe Biden. So if you want to publish something, or if you want to advertise something, Donald Trump is a more valuable person than Joe Biden. So he can influence things much faster than Joe Biden. And also this graph tells you like, probably if you contact this person, you can reach Donald Trump very easily. Or probably this person, if you know him, then you can reach Donald Trump very easily. So for all this kind of openness to understand the relationship between people, that's why this graph analytics is becoming very, very popular. Okay. 1 second, guys. Okay. Now this one is called LinkedIn graph. I'm sure you guys are all on LinkedIn, where you have put your profile. You've talked about your skill set. You talked about your languages. You talked about your city. You talked about your colleges, your work experience, everything. Now, this particular graph tells you what a person will have in a graph. So this is a person, okay? And this person has this skill set. He knows this language. He lives in this city. He worked in this organization on this year. He this is his education, this is his major, this is his degree, this is the literal level, whatever he is, and literal title. He worked in an organization with this position, with this title. So you can see how complex this information is. You can put it in a relational database, by the way. Don't think we cannot do it in relational database. But the relationships are so complex, it's almost difficult to represent it in relational databases. To query that information is very, very difficult. Now you would be able to appreciate now, I can query this graph database like, I want to know a person in Trichy who can speak Tamil and who is good in machine learning. Or I can say a person who lives in Chennai, works in Wipro, and he is interested in Java, and he did his MS Computer Science from St. Joseph's College. So all these combination of queries can be made on this particular graph. So that is why graph is becoming more popular. And these are all like normal data fetching, but there are other type of information. Say, for example, who is the closest person to me who can refer a job for me in Wipro? So I look out all my friends, and I keep on traversing the graph until I find a friend who is very close to another person who is working in Wipro or working in CTS, DCS, or any research organization. Say, for example, you want to do a research on graph analytics with machine learning. Now you can go and find out who is the nearest person to me, because if you talk to them directly, that makes it a lot more easier to communicate and all that. So you can find out who is the nearest person to my city who can speak Tamil, who is working on machine learning and graph analytics. Okay, so because of all these combination way of querying data is possible, graph database is becoming more and more popular, and also the hardware cost is also going down. The cloud technology is shooting up very well, so people are able to share their data pretty easily. As you see, this LinkedIn data is available to anyone as long as you are a friend of them. You'll be able to find out who is the closest guy to you. Okay, so that's why this graph analytics is becoming very, very important. You cannot afford to ignore anymore. That is what is happening right now as a researcher. Okay. Okay, I'll show you a demo right now, so it might look like so far what we spoke may not have been clear, but I will let you know, like, we'll see an example to see how it makes sense, or what we mean by a node, what we mean by an edge. We're going to deal with it a little bit deeper, but I'll just show you an example so that we are all on the same page. Are you guys able to see my browser where I'm typing Bill Gates?
Yes, sir.
Okay. So this Bill Gates is called a node. His name is Bill Gates. I'll add one more one, and I'll add another node. Okay. So his company is Microsoft, and we can add multiple properties. Their employees count is say probably 50,000. And add property. We have profit. They made a profit of say $15 billion. Okay. So now these two are nodes, and we have represented information, but there's no relationship between them. So to create a relationship, what we do is we drag and drop this here, and we say for this relationship, the type is chairman. Okay. And you can add property, say since 1995, and I'm sorry. Until say 2020, not 20, I think it'll be 17. So in this, the circles are called as node, the lines are called as edges, and these are all called properties. Chairman is a type, since is a property, until is a property, here name is a property, here name, employees count, profit is a property, and company is a label. Okay, when we say label, is nothing but similar to Java class. So this is a company Java class, and this is a person Java class, and this is a chairman Java class. Okay. Now let's try to add another node. This is okay. And what is the label going to be? The label is going to be person. And what is the property we're going to have? His name is Nadella. And that's it. Okay. And what about him? He's also a chairman now. Yes, since he's he's a new chairman of Microsoft now. So we say since 2021. Now this is a graph that we can draw to represent the peoples and the relationship with the company, and we can keep on adding this. So from this, it's very clear, like, you know, who was the chairman and who is now the current chairman, and you also able to know about the company, all that. Now, what we can do this, we can go to merge. Okay. So I'm going to use Neo4j Database. Okay. This database is used for representing graphs. Just see what happens. Okay. We had here. All right. Okay, and then so this is the graph that we have put right now. Okay, and so this is the actual Neo4j database you're seeing. This is the how the data is there in the system also. Like if you go look at the table, you can see these are all represented like JSON documents. Okay, so this is how the information is represented in the system. So for example, Kumar, he lives in Chennai, he knows Java. There's Rani, who's a bus driver who lives in Kowai. There's another person, James, who lives in Trichy, who knows machine learning. But from this graph, it's very easy to infer for you that James is not linked to anybody. They're all independent people. But in reality, that's not going to be the case. But this graph kind of tells you like how these people are independent of each other. They're not connected. And this one, I'll show you. So this one, yeah, company should be there, and the name. Okay. So Satya Nadella is a chairman, and this guy is also chairman. If you take the cursor over the edge, it will tell you at the bottom that what information we have here. And even when you put the chairman here, then you can see it is since 2021. So this is how a graph database looks like, and this is how it works, okay? And Neo4j uses a language called a cipher query language, and that is what I've just showed you here, okay? And you can write queries and all that on that. We'll see later on like how to write much simpler queries than, just like this query return lists all the nodes, but we'll go a little bit deeper later on to see how this query language actually works. It is very similar to your structured query language, but it is fine-tuned for graph databases. Okay. All right. Okay. So, do you have any questions on this Neo4j database, or what it is like? Did you want? Are you guys able to follow me? Are you fine? I see a question. Let's see. Okay. All right, so let's move on to the next slide. So in the mathematics world, they have a definition like this, which is nothing but vertices and edges. But this mathematical representation is not enough for our computer science people. So we have changed the definition, but okay, so there was one question which they said, if this big database, the graph looks clumsy, the graph looks clumsy, then what we do is, even though the graph looks clumsy, say for example, as I told you, they're concerned like, how will I make sense when the information is too high for when I'm looking at the graph database, okay? So that is why we have this one. I'll show you an example. In this example, there are tons of people in this graph, but we did not put everybody's name there. You see, there are gray dots, which means they are less popular. This orange dots are more popular. So that is how you represent the graph. So you don't put all the graphs together, and without any coloring, you will not be able to see it. But at the same time, you will be able to see the denseness of that of the graph. You can see, like here, you can see how thick all these lines are, versus here how thin these lines are. Okay, so just at a glance, you'll be able to pinpoint where the problem is, and that is why we are interested in this graph databases, because we want a higher level view, and then we can go deeper and deeper and deeper. Like for example, in this case, I want to know the most influential person is Donald Trump. Okay, why is he influential? Then I go look at his friends and how many tweets have been done and all that. So to draw a boundary around a problem, then we need these graph visualization tools actually. Okay, and that is where it is more useful to have an idea of the problem and then start digging deeper into that problem. Okay? And that is why we are, say for example, in this graph, I'm saying Donald Trump is a very popular person, but why is he popular? Is it because he's retweeting other tweets, or is it because people like his tweets? How do we understand that? Why he's popular? Now he is no more the president. Now go take the graph and see what happens. The graph will not be as thick as it is right now. So then you can conclude, hey, because he was a president of this country, he was popular, but he's not popular anymore because he's not the president of the country. Okay? So that is why we look at all this information, to have a glance and to have an overall idea about the system we are looking into. Okay? All right. Thanks for asking the question. Now, so the reason why I'm talking about this particular slide is because I don't want you guys confused with, in the normal days, how the mathematical world, how they talk about graphs versus we talk about graphs. But the algorithms are same, but the way we apply them is slightly different when compared to what we have there. Okay. So each node is called a vertex. I was calling it as a a node. It is also called as a vertex in the mathematical world. You can consider each vertex as a cell phone tower, and the orange lines here, you can consider them as the direct wires going between the towers. So that when you make a call, the call reaches the tower, and from the tower it goes to another tower, and then it goes to the corresponding party because they belong to a different carrier or they belong to a different city. So your information flows from this V1 all the way up to V5. Okay? So this is about vertex.
Sorry for the disturbance, sir. 1 minute, sir. Participants, kindly mute your audio. I request all the participants to mute your audio. Yes, sir, you can proceed, sir.
Okay. So, so each vertex is a cell phone tower, and each edge is a wire that goes between these two. So from this, it's very obvious. Like from V1, if I want to reach V6, actually you cannot reach V6 because there's no line going to V6. From V1, I can go to V5. So what this represents is nothing but I can understand how I should send my information, or to which tower should I send my information, so that I can make the connection much faster. And that's why we are looking into all these graphs. So that gives me an idea of how much redundant. So for example, in this case, if V2 is there, they can't communicate with anybody else. If you look at the tower V2, so then we need to find out why this V2 is not. So we need to have a connection either between V3 or between V1. All those decisions we make based on graph analytics. That's a little bit out of scope. But you can understand how we try to interpret looking at a graph. Okay? Not even analyzing the data or running any algorithm. Just by looking at it, you're able to make sense of it. So that's the biggest advantage of graphs. And you have edges, so you put E2, E3, E4. You can name the edges also, and these edges will have weights also. Like for example, if this was cities, like you have Trichy, this is Coimbatore, this is Chennai, this is Chengalpattu, like that. Then you put the distance between them so that you understand how far these nodes are or how close this person is, and then you try to find out the shortest path. And for those reasons, we have another concept called weights. So this is the mathematical definition, and let's see what happens in our 1 second. All right. So what next? Okay, we have defined what is a graph, and it has got vertices and it has got edges. Good. Now, how do we represent this in a software world? We have taken one simple approach, which is called the adjacency matrix approach. You can see here, the rows are vertices name. The columns are also vertices name. Whenever they are connected, we put a 1 there. So for example, V1 to V3, V1 to V3, there's this line. So we have put a 1. How about V1 to V5? Yes, we have put a 1. So from V5, it doesn't go out anywhere. So you don't have any 1s here. It is. From V4, we have a line going into V5, and that is why we have a 1 here. Okay. Now this is called a directed graph because the information will flow only in this direction. From V5, the information will not flow into V4. The example of this is one-way streets. So if you take a street as a one-way, then from V4 you can go to V5, but you cannot come back in the same road, and that's what this means. It's called a directed graph. When you have arrows, then it's called a directed graph. If you don't have an arrow, which means if you just have a straight line, which means it is a bidirectional. You can go either way. That's what it means. And so when you see V3, there's no 1s here, which means you cannot come out of, from V3, you cannot go anywhere. Similarly, from V5, you see here, there are no 1s, which means from V5, we cannot go anywhere outside. That's what this means. So this information kind of helps you understanding what it means, okay? And here you can see in V2 column also there's no one, and V2 row also there's no one, which means it is an isolated node. It's not connected with anybody. Okay? So that is the reason why we go in for this adjacency matrix, so that you can understand how the graph is. And if you put the weights along these lines, then it becomes a weighted graph. And instead of 1, say you put 100, or instead of this one, you put 50, which means that is a distance between those two nodes. That's what we mean by a weighted graph. In a weighted graph, it won't be 1, it will be some other value, including 1, it can be any other value. That is what we mean by a weighted graph. And what we mean by a cyclic graph is, from V1 you go to V3, then probably we go to V5 and then come back to V1. So if you start in a node and if you come back to the same node, then that is called a cycle. Okay. So now what is the definition of graph in computer science? When we say node or a vertex, but normally we only call it as node, we don't call it as a vertex. It's mostly used by mathematical people. So here is an example of how the graph looks like for a Facebook person. The person, the name is Jennifer, is friends with another person, Michael, since 2018. Okay, this one is person likes technology. This person works for a company. The name here is Neo4j. Okay, and you see always the relationship starts with a colon. That's how you represent it. And these are all the properties, okay, of that particular node. Okay. And also we have something called node schema. What node schema means? For a person, what are all the properties? It has to be well defined. So for some we call it as name. For another person we call it as first name. For another person we call it as last name. No, that is not allowed. Okay. Even though the graph will allow you to define, but you should make sure that you have the same property name for all the persons. So here it is a name. Here also it has to be name. It can't be something else. Otherwise you won't be able to analyze the data. Okay. But at the same time you have to understand the name of a person is different from name of a company. And the way we differentiate is because based on the label. Okay. Label is nothing but type of node. You can consider label as a table name. In the relational database world, these two are like two different rows. In the person table, this is one row in technology table, and this is another row in company table. You can imagine like that. And edge, as I told you, again, it's a relationship between these two nodes. For example, likes, it could be follows in Facebook or friends, like that. And these also can have multiple properties like this. They have only one property, but you can have multiple properties, and you can query also based on these properties. You can ask like, since 2018, who are all my friends? Or who are all not my friends anymore? All that you can mention it. You can query such information from the database. And remember, why we are attaching importance to these graph databases, because it's easy to query when compared to querying a relational database. So that's why these are becoming more and more popular. It's always about querying. Okay. So what are the operations that we can do on a graph? Okay. The operations that we can do on a graph is you can walk. Okay. So what does a walk mean? 1 second, guys. So what does a walk mean? It's simple. Go from one node to another node. That is called a walk. And you keep on jump from one node to another node. That is called a walk. Okay. So for example, in your cell phone towers, if I want to call a person, say from Trichy to Chennai, then the system will decide what are all the towers to be covered so that we can reach the person in Chennai. Okay, so that is what is called a walk. Obviously, also if a walk is possible, which means the reachability is also possible, which means I can reach the other person. If a walk is not possible, which means like I cannot reach that person at all. Maybe their cell phone was switched or their towers are not connected to our telecom network. So walk is very, very important in the graph analytics to understand whether they are even related or not. Okay. And more than these cell towers and all that, it's mostly used in nowadays disease identification, because they want to understand if somebody has cancer, do they have anything else? For example, did they have blood pressure? Did they have, pain in their chest, or did they lose weight? What did they have? What happened before coming up with a cancer patient? Now you cannot come to a conclusion with just one patient in mind, right? So now you need to analyze thousands and thousands of patients throughout the world to see what happens before a person is declared as cancer. They could have chest pain, and also to complicate it further, for a breast cancer patient may have a different symptom versus a blood cancer patient, versus a brain tumor person. So all this common, the relationships are becoming more and more complex. It's really impossible to do it without the graph database, and that is why all these systems like walk, everything's becoming important. Actually, we try to walk from one type of disease person to another type of disease person and see like how close they are, and then we conclude like, okay, if these are the symptoms you have, then it's most probably that you may end up in this type of disease. Like we said for corona, it's not that you have a cough, you will have a corona disease, but most likely you may have a corona disease. Okay, that's how we concluded based on all these type of analysis. All right. A path is nothing but a walk with no repeating node except possibility for the first and last. So a path is also a walk. The only difference is you don't come back to the same place at any point in time. So if I ask for you to give me the way directions from Trichy to Chennai, you cannot repeat Chengalpattu twice in your direction list, because why should I go to the same place twice, right? So that is a path is nothing but it's a definition wherein you don't go to the same node twice. So this makes sure that we are not repeating, or we're not losing our energy unnecessarily, and we are not wasting time by going to the same node repeatedly. So that is why a path is very, very important, and people make sure that we are getting a path. And obviously, when I have defined a path, we're going to talk about the shortest path between two nodes. It is nothing but the least nodes between two nodes. What is the shortest path between two places? So the shortest path is now interpreted in different ways depending on the domain we are talking about. For example, if I talk about diseases, then I talk about these two diseases, they always go hand in hand. They're very close. If disease A occurs for a person, then most probably they will be having disease B also. So that is the shortest path in terms of analysis for diseases. And if you think about a political person, how strong he is, or how much am I close to a particular political person, then again you try to draw the shortest graph. In a LinkedIn kind of environment or in a Facebook kind of environment, you try to find the number of nodes that you're away from the political person or the popular person. Then you know how far you are or how popular you are with that particular person. Okay, so that is how the shortest path is now becoming more and more popular. Okay. So what does graph analytics mean? Process of analyzing data in a graph format using nodes and relationships. So if you can represent anything as a graph, then you can start querying the graph. And if you start querying the graph, then we are done with our graph analytics. We are there with the graph analytics. So there are types of graph analytics like path analytics, connectivity, community, and centrality. Before going that, I just want you to refresh your mind in terms of what we are trying to tell you. Okay. So, okay, 1 second. All right. So path analytics is nothing but you want to find if does a path even exist, then we go for the shortest path. Then connectivity analytics is, as I told you, like how the systems are connected to each other, and if one system fails, does people get disconnected, and even if it does get disconnected, how many people are getting affected? That is more important. That's why they're talking about connectivity analytics, and it is more and more important in the cyber attack world. Because cyber attackers, they want to attack the midpoint of any connectivity. When I bring down this system, then how many of my other systems will get affected? As you all know, we have too many cyber attacks happening nowadays, and that's because they're able to identify which is the most connected node. We'll see what that means later. Community analytics is nothing but how do we find groups of people and what are they doing as a group? It could be like computer science groups, students, what are they doing, or people who take vacation, where are they all going? And if a person in teachers in particular college, what are all they doing as a community? Do they do a lot of community service? Do they work extended hours? Do they go for a vacation all the time? Those kind of information we're trying to basically understand the mood of the community. That's what we're trying to do here. And what importance they give for all that can be done by the community analytics. And centrality is nothing but how popular that person is. Okay, if I talk to this person, I can get things done. Or if I ask him to say something, then this person can go and influence so many number of people. Like, if a prime minister tweets like such and such a person has done a great job, then obviously he gets more attention. So that is because not that person is popular. That is because the prime minister is popular, and based on his popularity, the rest of the popularity is determined. That is what is called centrality of analytics. And why we need all this? Because we are trying to centrality. It's not only about on a good intention, it's also on a bad intention. What happens if the particular person is trying to create an attack on the community and he goes and talks to people, then you see from this guy, there are a lot of calls going out. Like, we would have seen in the police investigation also, if they want to find, was there any other person involved in the murder, then they try to analyze the calls and see whom all they called often, and based on that, they do that. That's exactly the centrality analytics. Okay, so let's talk about path analytics. So this is nothing but how close are you to the another person, as I told you. Like if you want to meet the principal of a college, how close are you? If you want a particular course, how do you do that? All that is a thing with this reachability. And there's another important concept called a diameter of a graph. Diameter of a graph is nothing but maximum length of shortest paths, which means like from a person from point A to point B, what is the minimum distance I have to take, no matter what two nodes are. Okay, so that kind of gives the level of connectivity that you have within the system. That's what it means. So like, for example, you take this example, shortest distance for vaccination. Now the government may say, hey, the distance between the shortest distance for vaccination should be 10 kilometers. So if it can, I shouldn't say shortest distance, the longest distance between the vaccination person, the vaccination hospital and the patient cannot be more than 10 kilometers. In that case, now you try to draw a graph between each person in the hospital, and if it exceeds 10 kilometers, then you're going to say, hey, we are not achieving whatever the government wants, so we need to open more vaccination centers so that we achieve that shortest distance. Another example is when we used to talk about in the Kamaraj days, where I think for every 10 kilometers or 5 kilometers, you need to have an elementary school. So what do? You put all the elementary schools as nodes, and then you draw all the villages from the elementary school. And if any of the distance exceeds 10 kilometers, then you say, hey, sorry, you're not attacking the problem in this particular village, so we may have to start another school there. And that's why, this diameter of a graph is very, very important to make sure we are not violating the basic norms of that, what are we asking for. And also now it is becoming more important in your WhatsApp forwarding. Now, I want to know whether your WhatsApp message is popular. How do I do? I look at the diameter. So what does the diameter mean in WhatsApp? So this is another important aspect in graph analytics. You need to interpret things, okay? How do I apply this graph analytics to a problem that I have in my mind? Now, for example, WhatsApp forwarding, I forward to a person, he forwards to another person, then she forwards to another person. If the chain is very long, then I'm a popular person. But if the chain is very short, I forward it to somebody and they just forward it to 2 or 3 people, and that's it. It's not going further than that, which means like I'm not a very popular person. So they identify who are all these people. The police will have always an eye on these people who are able to forward messages for a larger group of people, because they can influence anything. They may send some false messages. So the way they work it out is they try to find out the diameter of the WhatsApp forwarding. And if it goes very long, then they try to kind of, okay, these are the people who we have to be careful about. That we read this. So they cannot be reading everybody's tweet to understand whether that person is trying to do something bad or not, right? We can only concentrate on a few of the people, and that's how you do it. You reduce your size of graph to be analyzed by using such techniques as diameter. Okay? All right. So connectivity analytics. So what is connectivity analytics? Again, how well we are connected with each other. It is useful in power distribution network, especially if one electrical line fails, how many people will be affected again, how much the effect will be. So there are some main grid lines. If they get attacked, then the power is lost for people. And this happens, especially the cyber attacks case, is happening often in US because they have very old systems. And nowadays, since they're not replacing those systems, they're getting into cyber attacks. Now, there was a recent cyber attack in US for Colonial Pipeline. This pipeline takes 5,000 miles, okay, which is almost like 8,000 kilometers, all the way from Delhi probably to Chennai or more than that. The oil is flown through those pipes, and they cyber attacked that pipe, and we lost the petrol for a week actually. So we had to queue up before the gas stations and petrol stations to get that gas because they attacked it. So they were not able to transport that gas from to different parts of my state. So we didn't have gas for 1 week. Since we are almost remote in the Corona days, the attack was not very devastating, but it did have an effect on the economy of this country. I mean, at least the economy of our state, and also the prices of the gas, they went high. So now these guys, they understood, hey, you know what, if I attack this person of this place of the network, I can shut down the entire pipeline. So this is what is about the connectivity of the network. If it had been much more distributed, then we wouldn't have gone into this type of situation. So you analyze the connectivity. And you might feel, this is not such a complex problem because how many pipelines they are going to have anyways. But you always need to think to apply it in social media type of environment where you will see how scaling is very difficult. Of course, we're going to see it in the future slides. So community analytics, groups of connectivity, how these groups are operating. It's basically, like it could be any group. It could be a political group. It could be a terrorist group. It could be students belonging to a particular college. Students belong to a particular course. What are those guys doing? So, for example, students belong to a computer science group. They may be going to the tuition centers pretty often because they always want to be with the updated technology. They go with machine learning or they go with the graph analytics. But versus the other groups like basic physics or chemistry, they may not be going to the tuition centers that often. So that is how you understand how a community works. And also, they also try to understand how this community was formed over a period of time. Okay, so now we are living in a very, very sensitive world, right? And it's influence also, it's there, easy to influence people also. So they keep on watching how a community follows. So this type of analytics is very, very important, especially for criminal investigators. They want to make sure that, like for example, suddenly there's a violence happening in Vallur Kotam in Chennai. Then I see a lot of calls happening from that particular place. I can see that the network signals are pretty dense in that particular place. Then I immediately, send my police force to make sure like nothing bad happens there. So these type of analytics, they keep on happening continuously. So don't think like we just do it once in a day or once in a month. No, it is happening every day, every hour to make sure that we are not having any unwanted results. Okay. And if you the trick to all these analytics is you don't have a common algorithm. It is a domain that tells you what the algorithms. As I told you, if you want to see whether there is going to be a riot in some place, then you can see the signals are becoming denser in that particular place. So that's how you know that something bad is going to happen. All right. So what is centrality analytics? Of course, it is about most influential person, and we have a formula to derive the centrality score. The more the nodes with high centrality score, less is the centralization of the graph. Okay, which means like we have a formula, and for each person I can give a number. If the numbers are very similar between groups of people, which means the leadership is spread out. The leadership is not concentrated in one place. Like in a political party, you want to find out who's the most popular person. Is it the person A or person B? Is it the the general secretary of the party, or is the chief minister of that party, or who's that person who's more popular, or are they equally popular? Then you use the centrality score, and if it is same for two people, then they're equally popular. If the higher the score, that person is more popular. And this might help people to diffuse. Like they may say, hey, this person is becoming more popular, we need to reduce it. So they may bring in some new person, or they may swap this person so that the attention does not go to just one particular person. Okay, so that is what the centrality is all about. So how do you arrive at the centrality? It depends on, again, on the domain. Like a person is popular on Twitter, then he has many followers, or there may be many tweets, or there may be many likes. Facebook also, maybe they have many likes it is. Or you write articles, and if they get popular, if they get reposted in many places, then you become a popular person, and that's how you calculate the centrality analytics. One second, guys. Okay. So now we are coming to the end of the show, I think, almost, and what this is about is the big data. Okay. Now, big data is becoming more and more challenging than the graph analytics as such. Graph analytics on a big data is a very, very challenging environment because of the size, or because of the volume of data that we are dealing with. So for example, volume, size of the graph. Size of the graph is nothing but the number of nodes in the graph. Say, for example, Facebook, we have 1 billion nodes. Can you believe that? There are 1 billion users are there in the system. Now, how do I know? How do I analyze my community effect? How do I analyze like people are falsely propagating information? So that becomes very, very difficult to understand. So, and also in Facebook, it's not the person, it's a node. It's also a comment. It could be a posting. It could be a like. Anything is called a node in Facebook. So you can see it is going to be in trillions of nodes is going to be there. And not only that, another bigger problem is it is growing every minute and every second. So that is what is making it more complex, and all the more. And also, these information cannot fit in just one computer. It has to be distributed over all thousands and thousands of computers. Now, how do we connect them? How do we make sense out of this volume? All that we have to. It's a challenge, basically. That is what people are researching on. How do I represent graphs? And especially distributed graphs is a bit a tough task, basically. I'll tell you about that a little later. So velocity. Velocity is referring to edges over a period of time. So that is what is nothing but the velocity. So like, for example, you are a friend, another person is also a friend, and you say there are two persons, A and B, and you connect A with B, then they become a friend. So that's when a new edge is created. Then they like your post, another new edge is created. They post a comment, then the new edge is created between that person and a comment. And if a person likes that comment, then there's a link between that comment and the person who liked it. So the edges, they keep on growing at a very, 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 very fast pace. You know how many people are there on Facebook, how many times you like things and all that. So this is called streaming edges into graphs. I mean, we keep on adding edges into the graph, and the Facebook has to keep up with it, because when the next day when you log into the system, it has to say, hey, there's a new friend who's added in the system. Do you want to become a friend of him? How is this possible? They have to keep on analyzing the information, and that is why it becomes tougher. And this all have to be real-time information. And one more classic example of velocity is trending topics in Twitter. So in Twitter, you just say, I like Apple, then suddenly the Twitter then says like, hey, today it was I like Apple. That was a trending topic. But you should see the trending just happened just like that, in real time. Every day the topic changes, even every hour the topic changes. That's what they do, right? Hey, in the morning it was Apple, in the evening probably it's orange, in the night it was about the prime minister, or it's about the chief minister. So this is all because new images are being created and the systems are analyzing it very, very fast. Okay? These trending topics, they take too much of energy also. And these are all very interesting problems to solve. Variety is nothing but multiple sources of data. That is, I get information from LinkedIn, I get information from other sources like, for example, Facebook, or from Twitter, all those. When I get it from your college, from your government, all that, then that is all together. If you put as a one huge graph, then we call it as a variety. Valence is nothing but increased connectedness of a graph. We will see it in that another example. And this valence is the unique feature of graph analytics. It is not part of big data. For big data, we have only 3 V's: volume, velocity, and variety. The fourth one, valence, is specific to graph analytics. Okay. All right, guys. So far, are we good? Are we following? You guys are fine? All right.
Yes, sir.
Okay, good. So this volume, as I told you, the size of the graph increases. Now, why should we worry about volume? What is the issue with the volume? The size of the graph increases algorithmic complexity. Any algorithm you run, when there are more number of nodes, then the complexity as such increases, because most of the algorithms are n square in nature, square of the number of nodes. So as nodes keep on increasing, my algorithm complexity also increasing. So the volume has to be under control, if you can control it, by the way. The shortest route between two places which are far away, that is very, very difficult to calculate. So you want the shortest distance between Delhi and Chennai. They are very, very far away places. There are thousands of ways where you can reach the Chennai, and then it becomes very difficult to handle. How do we do that? That we need to, again, it's another challenging environment. Diameter of a graph, moving oxygen cylinders during pandemic. So you have, where all the oxygen cylinders are manufactured, and where the hospitals are. Now you need to find out from a oxygen generation system to the hospital, how far are they? So the diameter represents the maximum distance that a person has to go to get this cylinder delivered. Say if it is 100 kilometers, then definitely there's something wrong or something bad. That particular hospital has to be addressed. Maybe we ship more cylinders in advance, or we have in between another oxygen cylinder manufacturing utility, whatever it is. But the diameter will help you in understanding how far are these cylinders, and how far are these oxygen cylinders versus the hospital, and do we need to put in more oxygen cylinders, or do we put more in hospitals? Those kind of decision making can be made using this diameter of the graph. Okay. Velocity, as I told you, is trending topics in real time. They are very, very tough to find out because the problem with the velocity is every tweet is important. We cannot just ignore a tweet, right? Otherwise, we won't be able to get that tweet into the trending topics. So that is why this velocity is becoming very, very difficult to find, and it's also interesting. Am I supposed to stop the session, Rosalind, ma'am? Hello?
Hello?
Am I supposed to stop it, or what is it?
It continues, sir, if you have.
Okay, I have. Okay. Somebody said thank you, so I said, I thought it was. Because I remember the days where when you clap, which means you're supposed to stop, right? Not get encouraged. Okay. So I'll go ahead. Okay. Okay, so this trending topics in real time is again difficult. Okay, even in the volume case, you can ignore certain nodes because you want to arrive at the shortest path. But in the velocity case, you cannot ignore any node because you have to. And variety is different kinds of graphs. As I told you, like you have to put information from different places: Facebook, Twitter, LinkedIn, and then you try to make an attempt to understand that person. Say, for example. A person who's active in Facebook, is that person active in Facebook or posting also? For example, a person may be active in Facebook, Twitter, and LinkedIn. Then we try to understand, hey, why is this person active in all the places? Is he trying to be a propaganda person? Is he trying to propagate false information? So that is how it becomes, okay? And especially with the political material, then they become more concerned if a person is active in all the social media environment, okay? And valence is nothing but interdependency among data, popularity of an event or a person. Okay, so you try to find out, is this person very popular, or what is the dependency between these two information, like between, as I told you, between the diseases or between the courses they have taken versus the job salary they get. All that type of information we can get using valence. And you have also a formula to calculate the valence, and that again is in a way related to the centrality of the person. Okay. Yes, Mr. Kajal, I think you raised your hand. Kajal, you want to say something? You can put it in the chat if you want. Okay. All right, and okay, this is about this. Okay, we are coming to almost the end of the slides. Is now the biggest challenge of graph databases. How do we store and retrieve information? You can do it in RDBMS, very limited support for the graph operations. Remember, it is the graph operations which is pulling down RDBMS, like finding the shortest path. Is there a path available? Is there a walk possible? All that is not possible. Now, I wouldn't say it's not possible, but it's very, very difficult to implement those queries. And Neo4j is also a popular graph database. Tiger Graph is also a popular database, as I told you. I showed you an example in NeoGraph database only, wherein you can connect nodes and all that. So applications of graph analytics, fraud detection, supply chain optimization, utility optimization, and social media analytics as such. Now, the social media analytics, I work with a company which is very interesting is, like, how many people are talking about your company? And are they talking about in the positive way, or are they talking about in the negative way? Yeah. And this is useful mostly when the companies introduce a new product. For example, Coke introduced a new product called Coke Vanilla. Now, Coke doesn't know, do people like it or not? They may do huge advertisements, everything is fine. People may buy it also because it's advertised. But then they put in the Twitter and in Facebook, hey, this drink is not good, the taste is bad, or I couldn't get it in my city. All those information is there. Then they analyze it and then they tell folks, hey, this product is a hit or this product is a failure. So this social media analytics is becoming very, very popular among the companies because they try to understand, they try to know, or it's another way to get the feedback of their product. The reason being, these opinions are usually very, very honest. Okay, so you can understand, even if you may, sometimes people say, like, the opposition company comes and puts some bad reviews, but these bad reviews, they get drowned if there are too many good reviews. So that's how they say, like, it doesn't matter even if somebody gives a bad review, as long as you have many good reviews, you're fine with it. So that's why this is also becoming very, very popular. Okay. So the research topics is distributed graph database. In a cloud environment, distributed database is very, very difficult to implement. And also, like, in relational databases are also very difficult to implement in a cloud environment because the joins are not cloud-friendly concept. So it's very, very difficult to do a join in the cloud environment. That's why these NoSQL databases, they don't support joins. because it's very difficult to join the tables. They take a lot of time and it's very time consuming. And on a similar note, distributed graph database is also very, very difficult to partition a graph, all that. So people are also working on it to make it more scalable. And also the research topic is when to use graph analytics approach. Should I represent this problem in a graph or not? That is another research topic. Rdf processing. Rdf processing is nothing but to represent knowledge, and how do you process that knowledge? That is again a research topic. Detecting cyber attacks, enhanced machine learning. This is something that is becoming more popular nowadays because machine learning is also popular, and they want to help in feature engineering, test train split, and biased split. So these are all properties of machine learning. When you learn machine learning, you will understand what all these means. And machine learning, since we are involved with a lot of big data, we want to make sure that we want to reduce the size of the big data, basically, for us to handle it and to get the results much faster. So for that, we are using this fine-tuning the feature engineering and fine-tuning the test and train split. Okay. Okay, as a homework, you guys can try to create the movies as a graph and see how to represent a movie as a graph. Okay, that's it. So do I have a one? Yeah, that's it. Any questions, ma'am?
Sir,
Yeah, I've completed, ma'am.
you have completed. Okay, baby, proceed. Thank you, sir. Thank you for your presentation. It's an excellent presentation, sir. Baby.
Dear participants, if you have any queries, you can just post it in the chat box.
Even you can unmute your audio and speak. Resource person is available online. You can unmute your audio and speak.
We couldn't hear, ma'am. Can you just post it in the chat box?
Sir, this is a question. Sir, can graph analytics, just read the question.
Yeah, I'm able to see it in the chat, ma'am. Can graph analytics be applied in the field of agriculture for prediction? Yes, you can. And when you talk about prediction, we usually go with machine learning rather than graph analytics. But graph analytics can give you an idea of, a prediction. We normally don't use it much for prediction.
Participants, the feedback form is posted in the chat box. Kindly fill in. Any other clarifications you need?
Anyways, well, one thing, guys, graph analytics is becoming very, very popular. So I would suggest you guys all, look into it, at least in the initial stage. Because it's a growing field, you have a better chance of, getting into this field.
Sir, kindly share your mail ID and phone number, sir. In case they need any clarification, they'll contact you, sir.
Okay, I will send you in your WhatsApp, ma'am.
Even here, you can post it.
Oh, okay.
Maybe any query from second question.
Okay, ma'am.
Okay, sir. Thank you, sir.
Thank you.
Participants, the resource person has posted his mail ID in the chat box. Kindly make a note of it. If you have any doubt in future, you can contact him. Thank you, sir.
Thank you.
Over to Baby.
Here comes Mrs. Cheba to share the events of today.
Japa.
Good afternoon to all. I'm happy to present. Good afternoon to all. I'm happy to present a report on the session of the 5th day of the Faculty Development Program. The first session was on data analytics in healthcare. The resource person was Dr. Ramkumar Krishnamurthy, Assistant Professor, Department of Science and Technology, Vishwakarma University, Pune. The topics handled in the session included introduction to learning, role of AI, machine learning and its types, supervised learning, reinforced learning, deep learning, supervised machine learning, unsupervised learning, process of data analytics, big data, data analytics architecture Azure, role of data analytics in healthcare. The second session was on data analytics Neo4j. The resource person was Mr. Raj, Chief Software Architect, American Markets Corporation USA. The topics handled by him were graph analytics, graph databases, Neo4j demo, mathematics definition, store and retrieve graphs using RDBMS, graph in computer science, operations on a graph, graph analytics, types of graph analytics, big data in graph analytics, and applications of graph analytics.
Thank you, Mrs. Jabbar. Now we call upon Ms. Mercy Geraldine to propose the vote of thanks for the session.
Good afternoon, everyone. As William Arthur Ward once said, feeling gratitude and not expressing it is like wrapping a present and not giving it. It's my immense pleasure rendering the vote of thanks and expressing my sincere gratitude. I cordially thank the resource person of today's second session, Mr. Raj, Chief Software Architect, Amerisave Mortgage Corporation, USA, for sparing his invaluable time and providing us with an insight into graph analytics. Sir, your session was very enriching, providing an in-depth understanding of Neo4j tool for graph analytics. Thank you very much, sir, for the interesting session. I thank all the participants for their active, enthusiastic participation and support. Once again, I thank each and every one of you present in this FDP. Thank you.
Thank you, Thank you, Ms. Mercy Geraldine, for your gratitude. Sir, thank you very much. Thank you for available even at your midnight. Thank you very much, sir.
Dear participants, before you leave, some instruction. In the afternoon session, we are going to have your actual assessment from 2 to 3. By 3 o'clock, we are going to have our validity function. I cordially invite all the participants to take part in the validity function. We will start with a prayer and we are going to display FDP claims. Then welcome address followed by keynote address by Dr. G. Gopinath Ganapathy, Registrar, Bharindasan University, Chutrapalli. Then we expect a few of you can share your online feedback. Then there is a photo session. Please join with us for photo session by switch on your video. And then overall feedback submission. Then followed by vote of thanks. Thank you, participants. So from 2 to 3, you are going to write your assessment test. Wish you all the best. Thank you.